Here's another set of problems. 10 cards are numbered and lying face up in a row as shown. David turns every card that is a multiple of 2. So first he turns this, 6, 8, and 10. Then he turns every card that is a multiple of 3. So 3, 6, 8, 3, 6, 9, and so on. Even if the card had been turned over previously and is currently face down. He continues this process with multiples of 4 through 9. How many cards are then face up? So you have to make a table. So if you make a table, multiple of 2, card value, when it is up, you put a 1. So if you do that for all through 9, and if you add the column, then we see that the cards with even number of flips end up face up. So even number of flips are, 0 is even, right? So even number 1, 4, and 9, and 10. So there are 4 cards that face up. So it takes longer to make a table like this, but once you make the table like this, then the answers can be found very quickly. The equation x squared plus bx plus 36 has 2 distinct negative integer solutions. So if it's 2 distinct negative integer solutions, then what do you do? X squared, you have x squared, oops, then I still have in the line mode. I have to change that to append mode. X squared plus bx, was it 32? Let me check. 36, okay. So it's 36, not 32. So this is 36 equals 0. So both are negative. That means you have x plus p and x plus q. So we know that p plus q is b, and we know that pq is 36, but p and q are both negative. So we have to find 2 negative numbers whose product is 36. So 1 and 36, negative 1, negative 36, negative 2, negative 18, and so on. So let's see how we can do that. So if you look at that, we have minus 1, minus 36, minus 2, minus 18, minus 3, minus 12, minus 4, minus 9. The next choice is minus 6, minus 6. But what have they said? They said that 2 distinct negative. Okay. So since it's 2 distinct, it's here it says 2 distinct negative. So it has to be distinct. So that's why there is no minus 6, minus 6. And they're asking what is the sum of all distinct possible integer values of b. So b happens to be minus n plus n. So it's 37. Yeah. Apparently both are negative, then minus n plus n is going to be positive. 37, 20, 15, and 30. So if you sum these values, the answer is 85. How many integers between 100 and 500 have at least 2 3s as the digits? So if you look at in 300s, it's because it's 100, 3-digit number. So 300s, 330 to 339. That also includes 333, remember that, right? So these are 10 numbers. And then 303 with the first and last digit 3. These are 10. But then 333 we already counted, so we are not counting that, so there are 9 here. So that's why there is 19, not 20. The other numbers are 133, 233 up to 433. They're not counting 333 again because 333 was counted here. So there are 3. So 19 plus 3, 22. Okay. The average of 2-digit positive integers is equal to the decimal number obtained by writing one of the 2-digit integers before the decimal. So that means a plus b over 2 is going to be a, and then the decimal part is going to be b over 10. So that's what the question is. What is the smaller of the two integers? So if you solve this, you get a minus a over 2 equals b over 2 minus b over 10. So you get, you get a equals 4/5 b. So if you see, a happens to be smaller number because b is b and a is 4/5 of b. So a is smaller of 2 digits. Obviously, if you choose a as 4, b is 5. So if you see 4 plus 5 over 2 is going to be 9 over 2, it's 4.5, so it works. So the answer is 4. Okay, how do you do questions like this, which goes infinitely like this? Square root of 20 plus square root of 20 plus square root of 20. So it's easy. Let me show you this. If you write 20 plus 20, plus square root of 20, it goes on like this. Let x be this. Then x is also going to be 20 plus x square root, because the, oops, sorry about that.